Now, continuing with the section 2.2, I wanted to now get into the idea of a piecewise function. These are actually quite important. Like most or a lot of real world examples would require a piecewise function. You can't, in other words, a function where you need more than just one rule to define it. So a function that's defined by two or more equations over a specified domain is called a piecewise function. Piecewise. All right, so I used a portion of this problem as one of my intro problems. All right, so let's suppose we have a cell phone company that offers the following plan for a mobile hotspot. $40 a month would include 15 gigabytes of data. And then additional data, if you needed more than that, the additional data would cost 60 cents per gigabyte, okay? So when you're thinking about this, you don't need to graph it, but I wanted to kind of show you what's going on here. All right, so the independent variable is the number of gigabytes. Okay, of data. And then the dependent variable, the y-axis, would be, what it would cost you, right? So I did C of G, which is like the cost for a particular number of gigabytes, okay? The cost, and it would be just in dollars, okay? Now I'm not going to put all the tick marks in there, but the gist of it is that if you use, well, let me go ahead and do 5, 10, 15, 20, 25. So let's say this was the scale on the axis. So if I used 5 gigabytes of data, the cost would be, let's say that's 40 right there. The cost would be $40. If I used wanted 10, the cost would be 40. If I wanted 11, the cost would be 40. For anything up to, 15, the cost is going to wind up being 40, including 15, okay? And then more than that, if I want 16, then I'm going to have to pay 40 plus a little extra. So like, think about that. If I wanted 16 gigabytes of data, then for 16 gigabytes, then I'd pay the 40, and then I'd have to pay the 60 cents. I'd have to pay 60 cents times 16 minus 15. What that's doing is finding how much extra, how many extra gigabytes I was purchasing. I would need to pay 60 cents for every additional gigabyte. So like for 16, I'd be just a smidgen above 40, right? I'd be at $40. That would be $40.60, okay? So what's going to happen is after 15, this is going to start going up by 60 cents for every additional gigabyte of data, okay? So it's a piecewise function because one rule doesn't describe what goes on everywhere. You needed one rule for this, okay? So that would be the cost equaling 40. And then over here, you need the rule that the cost would equal 40 plus 0.60 of the gigabytes minus 15, okay? All right, we'll do more with graphing a piecewise function, but sometimes all you have to do is be able to understand how to use this. So piecewise functions are often, the rules are often given to you using a format kind of like that. So you have two rules. The cost equals either 40, okay, or the cost equals 40 plus 60 cents times G minus 15. Which rule you use depends upon your input. So see over here how they did C of G, so that's my input, right? That's my X value. So my G equals 10. So what you do first, you should consider these conditions first. is you look at how if G is 10, that means it's here. So I should use the first rule. So I would pay 40, okay? Now, when G equals 15, the top rule has the or equal to on it. I should use the top rule. So this was the top rule. This was also the top rule because it had the or equal to on it. So it'll just be 40. But 45 now fits the condition that G is greater than 15. 45 is greater than 15. So it's like you should be thinking, since 45 is greater than 15, use the bottom rule, okay? So even though the way they write it has these conditions over here are written after, they're actually what you need to consider first, so you know which rule you needed to use. So 45 was bigger than 15, so I need the bottom rule. So I'm going to take 40, take 60 cents, and what's happening here is when I do 45 minus 15, I'm finding out how many additional gigabytes, right? That's additional gigabytes of data by doing that subtraction. So that's going to turn out to be 40 plus 60 cents times 30 additional gigabytes. So that'll be 40 plus 18, so that's going to be $58, where these two were less than or equal to 15. So they were $40, okay? All right, so you need to be able to do two things. You need to be able to evaluate a piecewise function. So f of 1 can't have two different outputs because this is a function. Which rule you use depends upon which condition it fits. So for f of 1, what I would think is 1 is greater than or equal to negative 1, so you need to use the bottom rule. Okay. Negative 1 is also greater than or equal to negative 1 because of the or equal to. So for that one, I'm going to use the bottom rule. But negative 3 is less than negative 1, so for that one, I'm going to use the top rule. So again, even though these conditions over here are the last thing you see, they're the first thing you have to consider. You can't give me more than one answer to these because we have a function. So there should only be one output matched up with it. So for f of 1, 1 is my x value. And I know since 1 is greater than or equal to negative 1, I use the bottom rule. And the bottom rule just says the output's going to be negative 2. All right, the next question was f of negative 1. Negative 1 is greater than or equal to negative 1. So I need the bottom rule, and the answer is going to be negative 2. For f of negative 3, for that one, negative 3 was less than negative 1. I had to use the top rule, and that one does have a variable in there. So the negative 3 goes where the x is, and I work it out, and I get just negative 4. All right, now, on this one, the graph was just shown to you, but we're going to try graphing in a minute. So here's the idea. Those conditions, right? X had to be less. We had one rule when x is less than negative 1, a different rule when x was greater. So you notice how the graph changes right there? This dashed line isn't trying to indicate an asymptote, if you know about those. I'm just trying to separate my coordinate plane. Here's where x is less than negative 1. Here's where x is greater than negative 1, right? And then when you're right there, x equals negative 1. So when you're greater than negative 1, the rule would be that, I'm just going to use a y, that y should equal negative 2, because f of x is the same as y. And when you're less than negative 1, the rule that's in effect is y equals x minus 1, because that's the rule that you're supposed to use when x is less than negative 1. And so, see, y equals x minus 1 is a line, and you could graph it by plotting some points, like pick negative 3, plug it in, pick negative 1 and plug it in, and that would help you to get this right here. okay? And then when I'm to the right, I'm supposed to use that the output is going to be -2 no matter what. I always like plugging in the endpoint to see where it would be, and then plug in something like an x of 2 or whatever, and you're going to get a -2. So this point and that point, and then I'm going to connect them because I know they're lines. That's how I would have graphed it, okay? All right, so let's look at question number 5. These are just evaluating, still just evaluating. So on number 5, I need to evaluate the piecewise function, and what I look at is when x is -3, then I should be using the top rule. Okay? I think about when x is 0, I need to use the bottom rule because that's one that has x greater than or equal to 0. So that's the bottom rule. And then f of 4, I should also use the bottom rule because 4 is bigger than or equal to 0. So for A, I would plug in a -3 into the top rule and just work that out. -18 minus 1 would be -19. For B, I would plug in 0, and I would plug it into the bottom rule because 0 is greater than or equal to 0. So that tells me to use the bottom rule. And I would just get a 3 because 7 times 0 would be 0. And I also use the bottom rule for 4. So I'm going to do 7 times 4 plus 3. Okay, so that's going to be 28 plus 3. That'll be 31. And your answers are just those y values. Okay? All right, let's take a look at number 6. Here, we're evaluating this piecewise function that has 2 rules. One of them you use when x is not 5. The other one you use when x is 5. So this is when you use the bottom rule, when x is 5. These are the x's, aren't they? Okay. And then for something other than 5, you're going to use the top rule. Okay, so if I'm doing h of 7, then I need to be doing 7 squared minus 25 over 7 minus 5. So I'm going to have 49 minus 25 over 2. And 49, take away 25, would be what? 24. So that's 24 divided by 2, and that would be 12. All right, top rule, I would use that and only that for a 0, since that x value is not 5. So this time I would do 0 squared minus 25 over 0 minus 5. So I'd get a -25 on top because 0 squared is still 0, a -5 on the bottom, and when I divide that I get a +5. Right? And then for the last rule, if x equals 5, then the rule doesn't have an x on it. It's just the output's always 10, so I would get 10. And that's how you evaluate a piecewise function. Okay?